Hey, my name's Callum, and I'm going to talk about climate change and the tech community. I actually don't work for Samnez anymore. I quit like a month ago, but I didn't tell them until like 2 days ago, so that's my bad. So I'm from London, and last week I saw some daffodils. It was the first daffodils I saw in the year. I usually use daffodils. I see daffodils come up, and I'm like, it's Mother's Day soon. I need to buy some daffodils. But it's February. It's a bit weird. I was seeing daisies on the way here as well. They're not supposed to be here for another month yet. They're a month early. Because yet again, it's a familiar headline now where it's the hottest winter. It's one of the hottest winters on record, same as last year and the year before and the year before. We see animals coming out of hibernation all over the world, and we see photos from Russia of streets with no snow that should have snow on. And on the other side of the planet, they're having one of the hottest summers ever in Antarctica right now. I think Debbie's going to show some photos later. In Antarctica right now, last week it was 20.75 degrees Celsius, which is the hottest it's ever been. It had never been above 20 degrees there, and it was 20.75 degrees. Our planet is heating up, and it's a result of climate change. So I'm going to talk a bit about some science. You might have heard about this report in the news. It's the IPCC. It's the IPCC report called Global Warming of 1.5 degrees. But I just like a bit of a caveat. I'm not a scientist. I'm quite out of my comfort zone here. So forgive me if I get anything a bit wrong. So the IPCC are an intergovernmental body of the UN. They're dedicated to providing the world with scientific information on the risk of human-induced climate change. So this report they released, I think it was towards the end of 2018, and it's about the risk. It's about what will happen if the planet gets to 1.5 degrees Celsius above pre-industrial levels. So when they say pre-industrial levels, that means they're measuring against the average temperature from the late 1800s, so just before we started burning loads of coal for electricity and for the Industrial Revolution. So this report contains a bunch of scenarios about what will happen if we hit 1.5 degrees of warming and if we hit 2 degrees of warming. So it says there will be risks to livelihoods, food security, water supply, human security, and economic growth at 1.5 degrees. Interestingly, 1.5 degrees is what we're aiming for. That's the best, that's like the target, because we're already at 1 degree. So this report suggests a number of what it calls pathways. So it suggests a bunch of different ways we can stay below 1.5 degrees. It includes shifting to low or zero emission power generation, changing our food systems to move away from such intensive meat farming, for example, electrifying transport, planting millions of trees. But interestingly, I found interesting in this report, all the pathways it suggests to 1.5 degrees rely on the use of negative emissions technology. Now, negative emissions technology doesn't really exist yet. It's something a lot of people are working on, but it's not here yet. So there's a couple proposals like carbon dioxide removal, where, for example, we grow a load of trees, and then we burn them. We capture the power from burning them, but we capture the carbon dioxide and store it for thousands of years. And another proposal, and I think this is the one the report prefers, is solar radiation management, which uses something, I'm going to read this on the screen because I can't memorize this, stratospheric aerosol injection, which is where basically they put a balloon up into the atmosphere, they spray stuff into the atmosphere, and it reflects the sunlight away from the Earth. And this is what they want to use to try to cool the planet down, which I think it doesn't sound that great to me. It sounds a bit unnatural, like spraying stuff into the atmosphere. Should we be doing that? But that's what they say we need to do to survive. And also, everything in this report is probability-based. So it says if we do all these things, there will be a 67% chance that it will work. So I heard an interesting analogy about this. It's a bit like smoking cigarettes. You can say, OK, if you smoke 10,000 cigarettes, you'll probably get cancer. But that doesn't mean you can smoke 9,999 cigarettes. Stop there, and you'll be fine. So everything's probability-based. The more we emit, the more the planet heats up, the greater the chance of a catastrophe. Interestingly, this wasn't noted in the report, but if we take all the unconditional pledges from all the governments around the world, everything they've said they're going to do to address climate change, and if we work out all the carbon emissions from it, on the current unconditional pledges, the world is heading for a rise of 3.2 degrees, which is a massive increase over the 1.5 degrees in this report. And there's a few scenarios from 2 degrees. I think it says at 2 degrees, something like 100 million people will be killed or displaced. So it's like not good. If you've got some time, so the actual report is like hundreds of pages long, but there's a summary for policymakers, which was designed for politicians, basically, and their advisors, which is, I think it's around 20 pages long. I think it's worth a read. It's kind of scary. I read it, and now I'm scared. But yeah, I think it's worth a read if you've got a spare afternoon. And there was this report published, well, reported on yesterday. I don't know when it was published. It was published by the World Health Organizations, the United Nations Children Agency, UNICEF, and the medical giants at The Lancet. Yep, you can see it. The report says the world is failing to ensure children have a livable planet. And I think this article, I was reading this article, and it was talking about the future. It was talking about our future children. But I think we often think about climate change as something that will happen in the future, but I don't think that's true. I think all we have to do is look at the last year and all the natural disasters that we've seen in the last year. We saw Hurricane Dorian in North America, which killed 675 people. We saw flooding in North India that killed 1,900 people. We saw Cyclone Ida in southern Africa, which killed 1,300 and affected 3 million people. And I hadn't even heard about it in the news until I did some research for this talk. Of course, we saw wildfires in Australia. I think most people heard of that. It's estimated that it killed 1 billion animals, and it burned 103,000 square kilometers of land, which is the entire area of the Netherlands 2.5 times. It's a massive amount of land burned. And I also hear people say, this is the new normal now, this is the new normal. Oh yeah, by the way, so I got these, there's a link on the bottom if you look at the slides. I got these from a report from, it was Christian Aid. There's a report of 25 natural disasters in 2019 that were made worse by climate change. So they reckon all of these wouldn't have been bad without climate change, because climate change makes nearly every kind of natural disaster worse. The only ones it doesn't affect really are earthquakes and tsunamis that we know of. It affects droughts, it affects forest fires, it affects floods and cyclones. So this isn't really the new normal, though, because while 2019 was the first year where our emissions haven't risen, the first year, they'd been rising until then. We knew about climate change in the 1970s, but we've only finally stopped the emissions rising. But they're not going down yet. And also, there's a 40-year gap between the emissions being created and them actually heating the planet up, because obviously it takes time for them to get into the atmosphere and for it to have an effect. So it's going to get worse before it gets better. But it's not, I was about to say it's not the end of the world. It doesn't have to be the end of the world. So this is a slide. It's basically this slide, I forgot where it's from. What it says is that emissions need to fall by 7.6% every year until 2050, starting pretty much immediately. And if we leave it any later, then we'll have emitted more emissions, so we'll have to like cut emissions even harder. So the sooner we start, the easier it will be. The later we leave it, the worse, the more difficult it will be. But it's not all doom and gloom. If we look back at 2019, we saw that 2019 was a year of climate action. We saw organizations like Fridays for Future, started by Greta Thunberg, where students skip school on Fridays and go march, basically. We saw the global climate strikes in September. I think there's been a few more of them, where the student strike has invited adults to join them. So on the 20th of September 2019, we saw 4 million people around the world strike, or not necessarily strike. I took leave, because that kind of striking is illegal in the UK. And a weekend later, we saw 2 million people. It's the biggest climate strikes we've ever seen. And in the UK and more around the world, we've seen Extinction Rebellion. So in October in London, there were 1,832 arrests, which is the largest act of civil disobedience ever, largest act of civil disobedience in the UK in modern history. And there were more arrests around the world because that's their strategy for some reason. We saw climate emergencies declared around the world. Scotland, Wales, and the UK were first at the beginning of May, but we've seen lots of other countries now, including the EU, the whole of the EU, declaring a climate emergency in November. But what does that have to do with us? So we work in tech. So we work in tech. What does this have to do with us? We're not like digging up oil. We're not cutting down trees. We're working on computers. So when I didn't realize a lot of this until I was doing research for this talk, because I got interested in climate change first, and then climate change and tech came later. So I didn't know any of this. Well, I knew the first half of what I'm about to say. So the web is powered by data centers. Data centers are where our code ends up on. And data centers are powered by computers, and in turn, those computers are cooled by massive cooling systems. So data centers, in 2018, they were estimated to use 198 terawatt hours of power, which is 1% of the entire electricity usage of the globe. In addition, it's not just data centers, because we have to get data around. So we've got data transmission networks, which, again, in 2018, they used 260 terawatt hours of electricity, which is 1.1% of the power usage around the world. So if we combine them together, we get a roughly approximate number for how much power the internet uses. And it's an interesting number because it's huge. There are 9 countries that use more power than the internet. So the internet uses more power than where I come from. The internet uses more electricity than the entire United Kingdom. It's a massive amount of power. Also, these numbers aren't including device usage. So it's actually quite a small number, but it's even trickier to measure, so we can't really do it. Interestingly, the amount of emissions from this is probably around the same or slightly more as the entire aviation industry. So we hear we need to stop flying, it's bad for the planet. But then data centers and data transmission networks are using the same amount of power. And for a lot of us, the code we work on often has a higher carbon footprint than we do. So I know the place where I used to work, it was a lot of big data stuff. So I can do whatever I want outside of work, but what I do in work is responsible for quite a lot more emissions than what I do in my personal life. So what can we do? Because we are in control of all this stuff. There's a lot we can do. So for a start, we can make our websites more green. Most of this is fairly standard web performance stuff, so I won't go too far into it. But I've just got a few slides. So to start with, our pages are still getting bigger. As bandwidth gets cheaper and quicker, we're sending bigger and bigger pages. And as our websites get more complicated, we're sending bigger pages. But there's a lot we can do to cut that down. So the biggest things on our websites are images, videos, and fonts. So cutting them down or making them smaller or removing them entirely is a good way of doing it. So we can use SVGs where possible instead of using JPEGs or PNG images. We can minify and compress images and videos. We can remove unnecessary images or just lazy load them. So for example, if you've got images later down in the page, you don't need to load them until the user starts scrolling. We can load the correct sized images. So if you've got a 1,000 pixel wide image in a 100 pixel wide slot, that's not really necessary. And we can switch to using more efficient formats. For example, with images, we've got WebP, and for fonts, it's WAF, I think. So we can make our pages smaller. Another thing we can do is make our code more efficient. This is more important if you're a back-end developer, because front-end code, while it has an impact, isn't doing anything with like big data or databases or anything like that, which is the more power-intensive stuff. So making your code more efficient is not something I'm an expert in, so I won't say how to do it. I think it's a pretty big subject as well. But it stands to reason that the more computational power your code takes to run, the more processing time, the more time it will take to process, which means the more power will be required to do it. And we can also switch our websites to using cleaner energy. So there's hosting providers now that run on green energy, or they offset their energy. Although it's better to go with someone that uses green energy than someone who offsets their energy where possible. And also CDNs, there's a few CDNs that have started switching to more efficient power. Depending on your website, it might be the hosting doesn't matter at all. For example, my website, my personal website, is completely static, so the server is rarely hit. It's much more important that I use a green CDN than green hosting. And if you're using a CDN, remember to utilize caching, because it's much more, it's also faster to only hit the edge nodes of the CDN instead of having to go all the way back to the server to get the page. But it also means there's much less data transmitted, much less work having to happen. And all of this has the nice side effects that a greener website is generally a faster website. So as I said, it's all fairly standard web performance stuff. If you make your website smaller, or if you make it smaller, or if you remove stuff you don't need, it's going to load quicker, which means, so from an SEO point of view, Google like that because it loads faster. From a UX point of view, your users like that because they can access your site quicker. So maybe your boss hates the planet, and you're like, but I want to do something. So you can sell it to them from the point of view of, oh, I want to make the website faster, and that might work better. So if you're doing all this, one thing you might need to do one thing you should do, and before you do all this, is measure it. So there's a website which I found recently called website carbon.com, which uses factors such as the amount of data transferred and the energy intensity of the data, and whether you're using green hosting to work out the exact emissions of your website. And I'll just give a quick demo of it. And the keyboard shortcut I memorized for display mirroring is not working. Where is it? All right, so I can't really see what I'm doing. Cool. So this is website carbon.com. So you can put your website in, and it will tell you how much power your website is using, how much the emissions from your website are. So I'll use a demo website. I picked on the Vue.js Amsterdam website last year when I did my accessibility talk, so I won't do that again. It seemed a bit unfair. I'll test frontendlove instead. I feel I'm such a dick. Cool. So it turns out this website is 18 megabytes big. So it's responsible for more emissions than 96% of the websites they've tested. So if you scroll down, I'm scrolling down. Cool. So it says how much CO2 is being emitted, and it says that the site is on green energy, which is great, because if it wasn't on green energy, it would be using so much more power. So they've got a page on this website that explains how it works. It's pretty interesting. It's got it links to a load of papers around the average carbon emissions per gigabyte emitted for standard hosting or green hosting. Of course, this website isn't 100% accurate. It can't know what you're doing on the back end. It can only look at what you're doing on the front end. So this website is useful for knowing how good you are, but it's not useful for saying how to fix it. So a good tool for that is, this is going to be really difficult. So Google Lighthouse. Has anyone here used Google Lighthouse before? Cool. I reckon I'm at 50%. Cool. So if we run this, oh my, this is confusing. There we go. Oh no, where's it gone? Oh. Right. So if you make sure performance is ticked and you click Run Audits, It ran pretty quickly earlier, but then I was on the hotel Wi-Fi, not the conference Wi-Fi. So we'll see what happens. All right, so I did this earlier. So what it says is, what it will say if it works, is that basically every image on the page is being loaded as the page loads, and some of them are a lot bigger than they need to be. So it has a list of suggestions, it has a list of what you can do and the time it will improve by. So I think the top one is said it's unloading unnecessary images, where if you fix that by lazy loading them or making them smaller in this case, it says how long it will improve the site load by. So it said that if by getting rid of unnecessary images or lazy loading them, it will speed up the page load time by around 70 seconds. That said, it didn't take 70 seconds earlier. It loaded pretty quickly, and then I think it guessed the numbers backwards. So I'm going to give up on this and go back to my slides. Cool, so that was Lighthouse. So I'd recommend just everyone in here, just go test your website in websitecarbon.com, and then if it's bad, you can look in Lighthouse to see if there's any low-hanging fruit you can improve. So that's 3 things you can do to make your website more green. There's also other stuff you can do. So there's organizations like Climate Action Tech, or there's other more, so for example, if you work for Amazon, there's a collection of people who work there who've started their own climate action thing around trying to get Amazon to become more environmentally friendly. So Climate Action Tech, they describe themselves as a global community of tech professionals using our skills, expertise, and platforms to support solutions to the climate crisis. So at the moment, they're currently planning some activities around Earth Week. I think Earth Week is at the end of April. So they're planning some stuff to do, and they've got loads of resources on what we can do to make things better, basically. And another thing, it's something I think for most of us, we have quite a lot of influence. So the tech industry, we work across almost every sector of business. So we work in music, we work in journalism, we work for investment firms, and we work for oil exploration people. And a lot of us are in positions where we can go to our boss and we can say, hang on, this is really bad. I ran our website through websitecarbon.com, and it says there's a load of stuff we can do to make this better quite quickly. Can I have like a few days to fix this? And also, it'll make our site quicker and us higher in Google. So I think we're in a fairly strong position to be able to do this, most of us. Yeah. So in summary, the things we can do, we can make our websites more green. We can join organizations that help the tech industry as a whole become more green. And we can use our influence that a lot of us will have to improve the businesses we work for. So these are a load of accounts that I think they're just worth following. Some of them are climate in tech related. Some of them are more general climate activism or activism related. There's also a couple blog posts from an agency called Whole Grain Digital. They're the people who made websitecarbon.com. These articles are both really good. The first one is on how to choose a green web post. It links to a registry of green web hosts and says some stuff around how some people are better than others, and basically a lot of green hosting is bullshit. So it explains what you can look for to avoid that. The second one, 17 ways to make your website more energy efficient. It's pretty self-explanatory. It's a bit like what I just did, but in more depth. So that's the end of my talk. Yeah. So I think we now know a few steps we can do to. I hope I've inspired you to go away and follow those few steps to make your websites more green, to maybe have a bigger influence on the tech community. And let's try to do better for our children.